Thanks so much. Have a great day. All right, Mia, our last customer bought 2 meringues. Hey, mathematicians, it's Justin again, and welcome to the end of our neighborhood bake sale. Mia and I have been busy all day selling the delicious treats we made, and the cookies were a huge hit. We didn't have enough room to put all of our data on one line plot, so we needed to use a few to track our cookie sales throughout the day. We're hoping to get a clear picture of how many cookies we sold and which cookie was the most popular. What can we do with all this data to help us understand it a bit better and answer those questions? Putting it all into one graph could help. But we sold so many cookies. This is either going to be a massive graph or we're going to have to figure out a way to adjust it somehow. By the end of today's lesson, you'll be able to create graphs that show lots of data all together. You'll also learn how to use these graphs to identify patterns and answer questions about data. Have your guided notes ready, and let's tally up our big sale success. Here are the line plots with our morning, afternoon, and evening cookie data. Let's see. We sold 12 chocolate chip cookies in the morning, 9 in the afternoon, and 14 in the evening. It's kind of hard to keep track of all this data across 3 different line plots. What can we do to get all the data in one place? Let's add the cookie data from each data sheet. 12 plus 9 plus 14 equals 35 chocolate chip cookies. And 15 plus 11 plus 4 equals 30 peanut butter blossoms. Pause here to figure out the total number of snickerdoodles, jelly sandwich cookies, and meringues so we can have all our data in one place. So, based on the data, which cookie was the most popular? Interesting. The jelly sandwich cookies were the top seller, with chocolate chip cookies close behind them. Let's check out how the other treats did at the bake sale. I know we sold a lot of pies, cakes, and brownies, so let's check out the pictograph Mia made with all the data. Mia, is the pictograph finished? It is? But the data says we sold 14 pies, 22 cakes, and 20 brownies. Mathematicians, what do you think? Does this pictograph match the data? Pause here to record your thinking in your guided notes. Oh yeah, the pictograph has a key. This helps us know what the shapes represent. Notice how the key says 1 muffin is equal to 4 treats. So that means half of a muffin is 2 treats. So 4, 8, 12 plus 2 is 14, which matches the pie data. And 4, 8, 12, 16, 20 plus 2 is 22, matching the cake data. Well, 4 times 5 whole muffins equals 20 brownies. Nice. Why do you think Mia chose to have 1 muffin represent 4 treats instead of 1? Making an adjustment like that means she can show more data on the same graph. We're going to graph our cookie data next, but these numbers are even bigger than the treat data. How will we be able to show it all on one graph? What do you notice about the numbers along the y-axis? The bar graph counts by ones and stops at 10, but our data goes all the way up to 40. How else could we number the y-axis? The smallest number in our data set is 25, while the greatest number is 40. So we know we need at least enough room to get up to 40. Notice how all the amounts we sold are numbers ending in 5 or 0. Instead of counting by ones, what else could we count by? We can choose to skip count by 5s on our y-axis to help the data fit more easily. So now our y-axis goes from 0 to 50. Skip counting by 5s instead of 1s. We could show 35 above chocolate chip by building a rectangular bar that goes from 0 to 35. Pause here to finish graphing the data for the other cookies. When it comes to graphing data, we can choose how to skip count along the y-axis to help fit all of the data. This is called adjusting the scale. We're not changing the data, we're just changing the way we skip count. This helps us show these larger amounts while still making a normal sized graph that's easy to read. It's like how Mia adjusted the scale with her muffin shapes. Instead of representing one treat, each shape represented 4 treats. Oh, and she has another graph for us to check out too. Graphs can provide a lot of information, so what can we learn from the data on this bar graph? Pause here to record your thinking in your guided notes. This graph has the title Cookies Sold at the Bake Sale, with an x-axis labeled with the different times of day. What do you notice about the scale for the y-axis? Does it count by 1s, 4s, 5s? Looks like Mia counted by 10s. These must be some pretty big numbers. How many cookies were sold in the morning? That bar goes up to 60, so we sold 60 cookies in the morning. What time of day did we sell exactly 50 cookies? Looks like the evening. How many cookies were sold in the afternoon? The bar is exactly halfway between 40 and 50, so that's 45. When did we sell the most cookies? In the morning. And it looks like we sold the least in the afternoon. So how many more cookies were sold in the morning than in the afternoon? 60 is 15 more than 45, so we sold 15 more cookies in the morning compared to the afternoon. Let's use this graph to help us answer our final question. How many cookies did we sell during the bake sale in all? Pause here to record your thinking in your guided notes. So, what have we learned today, besides the fact that the jelly sandwich cookie was the top seller and we sold a whopping 155 cookies at the bake sale? Well, now you know that data can be collected and presented in different ways, and graphs can be used to compare, notice patterns, and answer questions about data. You've also learned that you can change the scale of a graph to show larger amounts of data. Be sure to complete the practice questions and extension activities that go with this lesson to practice working with scaled graphs. Mia, I am so impressed with how many treats we sold at today's neighborhood bake sale. Maybe we should take this bakery on the road. What would we need to start a food truck? Remember, mathematicians, in math, as in life, practice makes progress. I'll see you next time. Hey, hey.